Hello everyone, my name is Aditya Tiwari, Assistant Professor, CSVTU, Bhilai. In this tutorial, we are discuss about arrays and operations in linear array. So, before we start the operation part, we have to discuss about the what is array and why we require an array. So, in an array is a linear data structure that collects elements of the same data type and store them in contiguous and adjacent memory locations. Arrays work on an index system starting from 0 to n minus 1, where n is the size of the array. Suppose we have to store 10 elements inside the array, we require a free space nodes or memory from a free space memory. It will provide a empty nodes. We can fit the data inside the array. Array is a static type of memory data structure. We can define the static way in a predefined memory allocations. It is an array, but there is a reason that array come into the picture. Here you can understand how we design the array. First of all, suppose we want to store array is also a word. We have to store this word into the memory. And each letter will be stored into a node. Node is the smallest unit of the memory, like ARRAY. We can store one letter in each node. A in a single node, then R in another node, then R in another node, A is another node, and Y is the last node. We are storing our data from A to Y. Here, A, where we store, that is node is the lower bound address. And the last item, the last character Y, is stored in this at node, that is a upper bound of the address. So basically, when we call the node from the free space memory, a node having a self address also, and we can insert a new item inside the node also. Like that in this graph, each and every node having an address like that, where we store a having an address 11, where we store a R having an address 12, again R having an address 13, again A having a 14, and the last element Y having an address the 15. As I told you, array is a contiguous memory allocations. It means when we call some bunch of the nodes, when we require suppose we want to feed 50 items, we send a request to the free space memory and they provide a 50 contiguous memory allocation node. Then easily we can store our data inside the array type of data structure. Now, why do you need an array in the data structure? Suppose you want to feed some data, like right now I want to insert some marks, want to display some marks of the student in a memory. At that time we call a array. Suppose we are having a small amount of the students, suppose we are working on the 5 students, 6 students, 7 students, we can feed our data like that in a module 1, student 1 having a marks, this one, student 2 having a marks, this one, student 3 having a score, this one, 4, this one, student 5 score, this one. When working about the small amount of the students, we having a small amount of the student, we can go for the array type of data structure. But when we working about the above the big data, a large amount of the data, at that time array will be quite difficult. Let's suppose a class consists of 10 students and the class has to publish their result. If you had declared all 10 variables individually, it would be challenging to manipulate and maintain the data. If more students were to join, it would become more difficult to declare all the variables and keep track of it. To overcome this problem, array come into the picture. So, types of array. There are majority 2 types of array. They are one-dimensional array. You can imagine a 1D array as a row where elements are stored one after another. Like in this picture, we can store our elements. Elements means data. Each elements will be stored in each nodes, and as per the length of the data, we required a length of the nodes. And after we inserting a node, after we requiring a node from the free space memory, we also assign the indexing numbers. Like that, the first node indexing a 0, second one is a 1, third one is a 2, and so on. This is not an address, this is an indexing number. When we call a node, automatically the self address will be come from the free space memory. This is the indexing number, and indexing number is always started from 0, and the last upper bound address is depend on the length of the size of the data. Another multidimensional array. This multidimensional array are again of two types. The first one is a two-dimensional array. In a two-dimensional array, we are focusing on the rows and column. You can imagine it like a table where each cells contain elements. You can, in a three-dimensional array, you can imagine it like a qubit made up of smaller qubits, where each qubit can contain an elements. We can't display a 2D image, a 3D image on a 2D plane, but we assume that what we imagine that one in by this diagram like integer num. Inside the array parenthesis we pass a 2, 3 and 2. The first one is a row, column and any row 0. Second one is a row, column, again the 1, second one is a row. So as per this one, we can define one by one row, column with the row, row, column with the column. Like that we can define the multidimensional array. Now, how we declare an array? Basically, when we declare we want to declare an array is basically a combination of three types. First one, like that the statement integer marks 10. Here, integer is our data type. We have to design which kind of data we want to store inside the memory. If you here you write integer, either float, either character, it is based, when we declare that data type, it is based on the how much bits or bytes requirement from the memory. So we should to define the data type previously before we write any statement. So first one is a integer. Here I am writing a integer. Integer is a array data type. Second one is a marks, the name of that array. Here I want to insert or store the marks of the student. That's why I take a keyword that is a marks, and this marks is defined from the array name. And the last one is inside the parenthesis. Here we write a 10. It's a size of the array. As I told you, array is a predefined memory storage. We can call the free space nodes from the free space memory. We have to declare the array size. So all 10 nodes, before we starting the operation, all 10 nodes will be provided from the free space memory to the used space memory. So array are typically defined with square brackets with the size of the arrays as its argument. Here we can understand the syntax of the array. There are three types. The first one is a 1D array. In a 1D array, you can easily write int is a data type, array is a array name, and the size we can pass any number of size inside the single n in the big parenthesis and semicolon. In a 2D array, we can define same thing, int, again data type, array is a name, and we pass two parameter m and n for the rows and column. And the third one, in the 3D array, again we pass a data type, array name like a ARR, and we also pass the m and o as we discussed in the previous one. Now, how we initialize an array? You can initialize an array in 4 different types. There are 4 methods basically: method 1, method 2, method 3 and method 4. In a method 1, we have to store some marks from 6 students, like we have to declare a int, this is a data type, then we pass a array name is a, and the close parenthesis we pass the some values, like that we want to store the marks of 6 students. So we pass a 6 value inside the array, that is the size of the array. Now after declaring the size, we can easily insert the values. These are static values. We can define statically, like that int a6 equal to, we pass the 6 value 2, 3, 5, 7, 11, 13. This is the first method. The simple method, we can use this parameter, this type of syntax in a programming also. In a second method, again we have to declare a data type integer array. Here we don't pass any values. Now equal to, we directly pass the values in a dynamic time 2, 3, 5, 7, 11 like that. Now third method is a pass the integer n and pass some code. In a dynamic time you can call the values. We will insert via scanf, you can insert the values like that. Integer n scanf bracket closes started %d and address whatever, and we pass some loop like that. For loop we have defined for inside the bracket integer I is starting from 0, I is less than 5 and I plus plus. Here I store a 6 values. Why? Because I is started from the 0 and I will be working up to the is less than the 5. So, and after one operation, after inserting a one item in the one node, I will be incremented by the with the help of I plus plus, and by the scanf operation, by scanf function, we can one by one we can insert our element inside the nodes. The last method, here we declare elements like that integer array 5, array 0 equal to 1. In a first node having a address indexing number 0, here the value is equals to 1. In the indexing number 1, here the value number 2, indexing 2, value is 3, indexing 3, value 4, indexing 4, value 5. Now, you can access element of array in data structure with the help of the index at which you stored them. Let's discuss in this with the code. Here, as we know, the header files, the main function, user defined function, we have to declare a data type of the main function. Then I want to insert some numbers like values or items. So we have to define our data type and this name of the array, the size of the array, and we pass some values like that, 2, 3, 5, 7, 11 like that. One by one we can printf that values like that. Printf, when we pass some functions from pass some codes like that, what the value of array 0, what the value of array 1, one by one we pass all the values in our array. We call the values in the array to print that value inside the node. Like in a array 0 the value is 5, the array 1 the value is 10, in array 2 the value is 25, in array 3 the value is 30, in array 4 the value is 50, and so on. Whatever the element inside the array, one by one we can print that value by this C code. Now, operation you can perform on array. The operations are traversing, insertion, deletion, searching and sorting. We start from traversing. If you go for any operation like insertion, deletion, searching, sorting, whenever you performing any operation, traversing is much required. Without traversing you can't do any kind of a operation. So basically traversing is nothing else. Traversal is an array, is a process of visiting each element once. Whatever the element inside the array, in the size of the array, the one pointer will fetch each and every one at least a single time of every node. Here you can see the diagram. LA stands for the linear array, is a linear array with lower bound and the upper bound. If you see here we having a 5 nodes, the first node containing a 10, then 20, then 30, 40 and 50. The lower bound will be fetch on the starting position. Like here the lower bound we fix on the 10 and the upper one, the last element of the data length is a 50. Here we assign the upper bound at the node of the 50. Node is a 50 is an item, but right now store some nodes having some address, and the address will be initialized by the upper bound. So in a step 1, here I want to fetch all the item, whatever the item is available inside the array. So we assign some pointer. So we in a step 1 we assign one pointer. You can assign any number of key value. Here I take k. K will be assigning equal to lower bound. When you feed any item inside the memory of array, automatically lower bound and upper bound will be created. The lower bound with the starting position and upper bound with the end of the data element. So, we can start from lower bound, we assign a pointer k equal to lower bound. This is a initialize counter. Step 2. Now, we applying a loop. Repeat some steps 3 and 4 while k is less than or equal to upper bound. One by one we have to fetch all the elements inside the array. As I told you, array is a contiguous memory location. One by one all the addresses will be fetched by the k pointer from lower bound to the upper bound. Right now I fixed k pointer as in a lower bound address where the item value is 10. We are applying a loop from lower bound to the upper bound. K will be moved from lower bound to upper bound. So, we apply a condition k, the last position k will be working is less than or equal to the upper bound. In a step 3, apply process to LA of k. Here understand, k is a pointer, k always point to the address. Whenever you declare a LA of k, it means k inside the bracket, it means the value will be, item will be fetching by this process. We can insert, delete, searching any process inside the node. It means node is divided into two parts. First is the information and second one is the address. We can't manipulate addresses of the node. We can do updating the data inside the node. So, here we apply a process to LA. Right now we are only traversing with just the counting of the values. So, means that with the help of LA of k you just fetch the items only. Now, step number 4. When you reading the value of first node like 10, when you reading, you update the pointer. Update the pointer with the help of set k equal to k plus 1. It means increase the pointer one by one. Now, k will be jumped from first node to the second node. Now, the second node value is item is 20. And via the second step 2 loop, we are inside the loop. Again, k will perform same operation, read the second element, second node element, that is a 20, then 30, then 40. When k move to the last upper bound address, at that time, in the condition k is less than equal to upper bound, the first condition is false, k is less than upper bound, it means it is a false, but k equal to upper bound, it is a true. One of any condition is true, it will work. So, k is less than upper bound, it is false, but k equal to upper bound, it is true. Then we move to step number 3. Now, again we apply a process to LA of k. Again we visit that element, we fetch that element. Now, again we update the pointer k equal to k plus 1. Now, k will exceed the upper bound size. Now, condition will be false. Now, the program will be terminated. So, end of the loop and finally, we exit from the program. So, by this traversing, we fetch all the item one by one with the help of k pointer from lower bound to the upper bound, and finally, when the k pointer will be exceed the size of the upper bound, directly terminated by the exit operation. So, here you understand how we insert a new item inside the array. It means before we inserting, we already having some item inside the array. By this insertion operation, you can insert a new data element inside the array. Suppose we are talking about your mobile contact list. Already lots of names are available, contacts are available inside your phones. Suppose a new friend will be arises, you can feed the new contact number, and it will be stored not all postfix, it will be stored at the appropriate position. Suppose you are having a lot of the alphabets A, B, C, D friends like that. Now, the new friend is Sachin. Sachin will be added inside the contact list. Sachin should be stored at the appropriate position inside the array. So, we can fit that item, but we also follow the property of array like a continuous memory allocation. So, here LA is a linear array with n elements and k a positive integer such that k is less than or equal to n. This algorithm inserts an elements item into the kth position into the array. By the searching algorithm, we already find out the location where we want to store our new item inside the array. The kth position already fixed. We already discussed this, how we analyze or how we point the kth pointer at the location, how to find out the location with the help of searching algorithms. We can discuss that part on that video. Searching like linear search or binary search, we can find the location. Right now we focus on the how we insert a new element inside the array. So basically at that time we want to some parameters like linear array, n stands for the number of elements, k at the location where we want to insert a new item inside the array, and what kind of item you have to store the location of that kth position inside the array. By this example, we can easily understand how we insert a new item inside the array. Here the step number 1, given an array with elements. Suppose you can understand by your mobile contact list. Suppose we having some items, we call some array, we have to declare the size of that array. Here I am declaring the size 10, the indexing, the nodes having a indexing 1, 2, 3 up to the 10. Also we feed some items A, B, C, D up to the I. Here A store at the lower bound and I will be stored at the upper bound. A, the indexing number of A is 1 and the indexing number of I is 8. This is before we inserting any element. Now we have to store the new element that is called a F. F will be stored after E before G. It means the location is 6th. Right now G is holding the 6th position, but we want to store a new item that is called F. F should be stored after E but before G. In a step 2, why the searching algorithm? We have to find out the location. The location will be find out at the 6th location. 6th, it means the indexing number 6. Right now G is already available at that position. Suppose here you insert, you call the operation insert F at that location here. So F will be overwrite on G. So G will be removed from the list. So the final list is A, B, C, D, F, H, I. G will be removed. This is not perfect operation. We have to insert a new item. We also maintain the array list also. So we have to free that node from the previous element. So how we free that node? So we call the upper bound address. We fix a new pointer. Right now here we fix a new pointer j at the upper bound address, and we take some decision from j. J having a new, so array size is already at 10. The upper bound right now holding the 8th position only. So we having a space empty space nodes inside the array. J is already pointed at the upper bound address right now in the 8th position. The 9th and 10th address already free. So why this insertion, or before we starting insertion, we swipe the items from one node to the another node. Like that we initialize a j at the upper bound address, and we also call the j plus 1 pointer. J with plus 1, it means where the j is holding the position, the j plus 1 is the successor of the jth node. It means j plus 1 holding the 9th position, that is the empty node. So we swipe the item I from 8th position to the 9th position. So we forwarding the item from 8th position to the 9th position, j to j plus 1. Now as per the algorithm, j will be decrement, and now j will be holding the 7th position. Again we update the pointer. Now j holding the 7th position and j plus 1 holding the 8th position. Now h will be forwarded from j to the j plus 1th position, and again j will be updated. Now j will be holding the 6th position. Here k is already holding that position. So, we apply a loop, j will be doing the operation up to the k. So, the same node 6 we having a k pointer also, we having a j pointer also. Again we forward the g to the j plus 1. Now, all the elements are shifted up to the k, all are shifted to the forward the location. Now, where the k pointer will be located, or we can say j pointer will be located, now we insert a new item f into that location. By this operation we can insert the new value f, all the data remaining are as it is, but the last elements where the insert a new element, all the data will be shifted one position, one successor node to that location. In this diagram we can understand this thing. So, after inserting the f, the k, here you see the kth position, right now inserting a new elements f at that position, and the remaining data are as it is. The difference is that where the before inserting g holding the 6th position, right now g is holding the 7th position, h holding in previous one 7th position, and here the 8th position, I updated with the 9th position. So, after inserting a single element, the length of the size of the data is also increased. Before the insertion the length of the size is 8, now the length of the size is 9. So, upper bound will also updated reset at the 9th position. So, insertion in an array is the process of including one or more elements in an array. Insertion of an elements can be done at the beginning position, at the end position, and given index of any array. You can insert a new element at any position of the array. Now, we can understand the pseudocodes how we insert a new item inside the array. So, step number 1, set j equal to n. It means here we assign a new pointer j where at the upper bound address. Upper bound address we can define by the nth number of element. Nth number of elements always holding the upper bound address. So, we assign the pointer j equal to n. Now, step number 2, we are applying a loop. Repeat step 3 and 4 while j is greater than equal to k. As we know, k holding some position in meanwhile any of position of array. So, j will be right now we are pointing j at the last position, and j will be come with the help of decrement pointer it up to the k. So, j will be working when we greater than or equal to the k. In step 3, here we move the jth element to the downwards like that. Set L of LA j plus 1 equal to LA of j. It means we can assign the value of item of LA of j equal to LA of j plus 1. We shifting the item from jth position to the jth plus 1 position with the help of syntax LA of j plus 1 equal to LA of j. In step 4, set j equal to j minus 1. It means decrease the pointer one by one. When you shift one element from jth position to j plus 1, you have to decrement the pointer j one by one. This is a process is going on till when j is greater than or equal to k. When j is less than k, the operation will be stopped. Directly we jump to step number 5, and step number 5 here LA of k equal to item. The operation will be stopped only a single position when j and k both are pointing the same location. So, here we now insert a new item with the help of syntax LA of k equal to item. Now, step number 6, set. After inserting a new item inside the array, automatically is directly proportional to the length of the size will be increases. So, we also increase the size, like we update the upper bound address, like with the help of syntax set n equal to n plus 1. We reset the upper bound address, and finally, we can exit from this pseudo code. Move on the next operation, that is called a deletion. Deletion in a linear array. Deletion of an element is the process of removing the desired element and reorganizing it. The element is already available inside the array. We delete that item, we remove that item from the array and we generate a new list. You can also deletion in a different way, like at the beginning end, at the end, or at any position of element. Here you can understand, before deletion we having items like that inside the array 10, 20, 30, 40, 50, 60. The 6 elements are present inside the array. Now we have to delete 40. So after deletion have to see the array 10, 20, 30, 50, 60. Here 40 is removing, but after removing the 40, the space is not empty. That space is filled by the successor item, that is called a 50. Now again 60 is also shifted to the 50th position. What I want to say, the principle of array, we can't empty node inside during the array. We have to fill by the successor item from the another node. By this example, we can understand how we delete an item inside the array. Before deleting the array having a data like that A, B, C, D, E, F, G, H, I, it means the lower bound is fetched at the first position, that is for the first position at the indexing number 1, and the upper bound is right now located at the 9th position of the index. Suppose we find a location of any item, where the location, and we have to delete that item. Suppose we want to delete the F from the array. So with the help of searching algorithms, we have to find out where is F will be stored in the array. When we search out, the location will be fixed. Here the K will be fixed at the position number indexing number 6. Right now we want to delete, user want to delete the item F from the array. Here F will be situated at the indexing number 6. So we assign the pointer K at that location. K fixed. We also fix another pointer J, where J, we assign J equal to K. So J, when want to delete an item F, as I told you, it will be, that node is not empty, it will be replaced, it will be filled by the successor items. We assign J, so we also call the J plus 1. We call J plus 1 data to move to the jth position. Now G, F will be replaced by G, G will be replaced by H, and H will be replaced by I. It means one by one all successor nodes item will be shifted to the predecessor node. F replaces by G, G replaced by H, and H replaces by I, like that. So after deletion, the array looking like that, F will be removed from the array. The data items are A, B, C, D, E, G, H, I. Here F will be removed, K pointer, the pointer of K, where now it is holding the new data item value is G. So again we reset the size of the array, we update the pointer upper bound. In the previous one, before deletion, upper bound will be holding the 9th position. Now after we reset, the upper bound will be holding the 8th position after deleting the operation. So by the pseudocode we can understand, then step number 1, set item equal to LA of K. We want what we want to delete an item, we have to assign by the pointer with the help of K pointer. In the step 2, we assign a J equal to K and apply a loop to the K to the n minus 1. Set, we transfer the data item from jth plus 1 position to jth position, and this will be continuous in a loop, and so end of the loop. And finally, when we shifted all the items to the kth position up to the kth position, we reset the n equal to n minus 1, and finally we can exit from the deletion algorithm. Thank you.